Hello everyone, I'm going to discuss a sample problem about the thermodynamics and heat transfer, and this is in chapter 4, the first law of thermodynamics. So here it is, the sample problem. A 60 cubic meter room has a 40-liter electrical radiator filled with heating oil. The oil in the radiator and the space are both initially 20 degrees Celsius. It is now time to turn on the 1.7 kilowatt radiator. At the same time, the room loses heat at an average rate of 0.45 kilojoules per second. After some time, it is discovered that the room's average temperature is 25 degrees Celsius for the air and 55 degrees Celsius for the radiator oil. Determine how long the heater is left on by using the oil's density and specific heat, so which are 950 kg per cubic meter and 2.2 kilojoule per kilogram degrees Celsius respectively. So assume there are no air leaks and that the room is tightly sealed. In this question, we have here that the air is an ideal gas since it is at a high end temperature and low pressure. So it's constant specific heats. So we have here. So it can be found in the table A1 in our property tables. So the given is the workout. So the work rate of this is 1.7 kilowatt, and then the average rate of the heat lost during this is 0.45 kilojoule per second. So for air, we have this. The pressure is 100 kilopascal, the volume is equal to 60 cubic meter, and the temperature 1 is equal to, the initial temperature is 20 degrees Celsius. This is in local atmospheric pressure, so this is equal to 100, so the pressure is 100 kilopascal, and the remaining specific heats can be found in table A1 and table A2 in property tables. So in the next slide, we have here the net energy transfer by heat, work, and mass. So this is equal to the change in internal and kinetic potential energies, and this is the equation for this one. So it is equivalent to this equation, the mass times its specific heats and times the change of temperature in air, and the same to the oil. We have the mass times to its specific heat times the change of its temperature. So the mass of air and oil are, so to get the mass of air, we have this equation, the PV over RT. So substituting all the given values here in this equation, so we have these numbers, and this Celsius was converted to Kelvin, so that is plus 273. So calculating this, we have this answer, 71.35 kilogram. So same to the mass of air, so we will get this mass of oil, so just multiply the density and the volume, which is converted to cubic meter. So the 40 liter is equal to 0.040 cubic meter. So multiply this and we'll get this 38 kilogram. So next is, so we get the mass of air and the mass of oil. So let's solve for this equation. So we have this equation, so let's use it to solve the time. So here, substitute all the given numbers to the time and we'll get this 2,546 seconds. So converted to minutes, so we have 42 minutes. So that is the final